Okay, today's problem is 1668. I recorded a video when I was solving that, but the sound was not there. So I'll re-record it and I'll try to optimize somehow. Um, yeah, so the problem is I need to I have a sequence and I have possible subsequence and I need to find the maximum number of times this subsequence repeats in this sequence, and I need to output the number of times it repeats after itself. The pattern of words repeats itself in the sequence. There shouldn't be gaps between the words in a sequence, and also if there is no occurrence of word in the sequence, I should return 0. So the starting from like the example that was given, it's A, B, and then C, and the word is AB, and this is a string input. So I'll have DP array of I, and then here gonna be 0, 1, 2, 3, 4. And DP array DPI will say, let's say uh, for the word that ends at I, for V that ends at I, what is the max uh, pattern length pattern length of V at in string or 14 string. So for the word that ends at 0, I have a pointer pointing to the word and pointing to the string. If it matches, I move the pointer further to the left, and here to the right. Oh, to the left also. If it doesn't match, I'll just put the 0 there. So it doesn't match B, it doesn't match with A here. So I move pointer to the next one, B match, then I move pointer here back, A match. So now I got a match, and I need to basically do, because so dp of I is defined as if the V S ends with V, then it equal 1 plus dp of I minus len of V. If this one is negative, then this part gonna be just 0. Otherwise, the value is equal to 0. So in this case, I have a match in the word, so I need to like do 1 plus something, and that something should be like B index. So 1 minus length of V, it's 2. 1 minus 2 gonna be minus 1, so it's gonna be like 0 here. So just 1. And then again, I'll start looking for the next, move the pointer to the A doesn't match with B, so I put 0, then I move pointer to the B here, A match with B, yes, then I move to the left pointer, and here move pointer to the left, A match, so I should go here, 1, not like this. So the output here should be something like this. Check, check. So it should be 1 plus something dp of 3 minus 2 gonna be 1. So 1 plus 1 gonna be 2. 1 plus 1. So gonna be the value here should be 2. And then I move the pointer again here to the end and here to the next character. C and B don't match, so just 0. And the maximum here is 2, so the output is 2. So that's it. Space complexity um, gonna be of n, because I need to save a DP array, and the time complexity. So the time complexity, because if I'm gonna have a matching ending, so I need to go one by one. So in the worst case scenario, like I'll have something like, yeah, but yeah, it's hard to assess right now, but I assume it's something like O of n. So I'll create an array int dp equals new int. Let's say I'll have int s length. Yeah. And then for int I equals 0, I less than n, I sec len I plus plus, and then I'll have the output equals 0, and then I'll check. I have a boolean match equals true, and then for in j equals I, j should be greater or equal greater than j minus I. Oh, j minus I minus len word len. Let's say int word len equals word dot length I minus word len j minus minus, and I check if sequence char at j is equal word char at j. So it should start from the end. So the word char at so I need to calculate from the j minus 1 plus word len. It might be easier to start with the word len. So let me change it. For j equals word len minus 1, j greater or equal greater or equal 0, j minus minus, and then word at j, and then sequence gonna be I minus j minus word len, something like that, minus 1. If it's not equal, I'll go put the match equals false and break. And then if match If match, then I'm gonna go dp of I gonna be equal 1 plus if the dp if the I minus word len greater or equal 0, then dp of I minus word len, otherwise just 0. And then output equals mass max dp of I, and then output. And then else dp of I equals 0, and I'll return the end, I'll return output. Okay, so like again, this one can be I minus this one can be negative. Okay, let me think about this. Why is this falling? Let's assume this one is growing, or like this one is decreasing. Okay. Okay, let's check what the people have over there. Can we reduce this problem to, like, first of all, fail because I made a small typo there. Second of all, can I improve this one? Instead of like having linear space, um, have something better.
I need to actually go to the bathroom.
Can I have just a number instead of a DP, like two numbers? The latest sequence index where it ends. Instead of this DP, I'll have the int latest index int latest frequency. If match, I'll say latest index equals I, and then latest frequency gonna be uh, increased, and then I'll save the output. Mm, interesting. Not really. I need also a condition if there is a break. Something like if match, if I minus word lang equals latest index, then I'll increase the frequency. Else, I will put the latest frequency equals 1. No, not really. Word AA. Match. Let's say I'm here, latest index should be. Oh, I'm here, match. Ah, I got it. So like it confuses a lot this. Oh. Can I still do the of one constant space complexity for this problem? I guess I can reduce up to the word len dB of I. But that means I need to move it always. Like to move elements in that array always by one. Okay, let's check what have memory. That's so weird. Everybody is solving with this sequence. Okay. This one seems like a constant space.
Dad, do you know what Charlie is?
No, I have no idea. So yeah, I've been looking on this algorithm. I was trying couple of checking couple of the solutions. This was one was pretty interesting one. So it's just simple. Uh, we add the word as a temp to the string builder, and then we add it a couple times, and as soon as if the sequence contains a word, we try again to add the if the sequence includes the temporary word, we'll try to increment the counter v, and then we'll try to add we add to temporary word another word, and again check the if it contains or not, if the sequence contains, like pretty brute force, but it's interesting because it gives a good memory execution time here. I wonder what the time complexity for this one, but uh, the one that I found interesting, all of those are pretty much the same algorithm, like sequence, we add, um, we add it, we check if the sequence contains this temporary word, and then we proceed. And then I found during this previous time, I found this one, this solution, and it basically what it does, it starts from the beginning. It goes from the like character 0, and it goes through the sequence, and it tries to see if there is a match for the word, and if there is a match for the word, uh, it will increment the count, and it will reset the pointer to the beginning of the word, and then on like, so it's like pretty much like this one. Check, check. Yeah, so it's like A, B, A, B, C, and then the word is say A, B, and the string is this one. And what they do, they let's say the pointer initial here, and they have like check this pointer equals this pointer, then they move like to the next one, this one equals this one. Okay, we at the end of the word, so we reset the pointer, it now is pointing here, this one equals this one, and we increment the counter here, counter equals 1, and then we do it again. Pointer is here, we check, okay, we move the pointers, pointers now pointing at B, okay, it match, and it's also at the end of the word, so we change the counter, counter becomes now 1, and now this one doesn't match with A, so we reset, we don't move the pointer, and we pointer in the word, we move the pointer in the sequence pointer is now like equal length, it's out of the bounds, and we finished. And then the same procedure will be repeated, but for the substring that starts at B, and initially so here the counter was 2, and that one was saved to the output, and now the pointer for the sequence starts not from the 0 index, but from the first index. It checks does B equal A? No, so we move um, the sequence pointer. Does A is equal A? Yes. Then does B equal B? Yes. So this here counter equal 1. We check the output. Output was 2, so we don't change the output. So again, we reset. I reset, or like they reset the word pointer. Currently A not equal C. So again, move just the sequence, and we at the end of the sequence now. And then they will do the same. Counter is still less than output, so we don't update the output. And then the iteration will start from a second index, from A, and again A is equal A, B is equal B. So yeah, and so the counter becomes 1. I check again the output. No, it's not greater. AB, so like then C not equal each other. Okay, so we move just a pointer to the sequence, and now we at the end of the sequence, and then the next iteration, it will start from the B and check if the B is equal A. It is not, so move sequence pointer. Then is C equal A? No, then move sequence pointer. And then sequence pointer is pointing to the end of the string. So exit and output the result here. This is the problem with this approach is it's pretty time consuming. So we check this substring, or like subsequence, then we check this subsequence, start going from the beginning to the end until we see there is no matching for the word. And we check this sequence, subsequence, and this subsequence. So it's not that, I would say, efficient, and much better than, and it's like not as good as DP approach I showed. In DP approach, I was just checking here, like time complexity should be O of n squared, around O of n squared. But for DP approach, the time complexity would be probably O of n by m, something like that, where m is length of the m equal length of word and n equal length of sequence. So that's it. That's all for this problem. As I said, failed because there was some errors here and there. And plus, I tried to optimize for this. I tried to optimize for this what for this DP array and didn't manage to find a good solution for that one. And it's like it seems like it's not possible to make it like O of one and O of n by m of or like constant memory and O of n by m time complexity. That's it.